We talked about continuous review inventory control before. Here I will continue to talk about some basic concepts and ideas about inventory system and supply chain, which is about measurements. And I will start with a basic surface level definition first. This is a very common vehicle for us to measure and evaluate the performance of a supply chain or an inventory system. We call it surface level or fill rate. You can see two scenarios on the slide. For each scenario, we try to place 5 different orders, each order corresponding to a particular part type. The numbers in red rectangle are the quantities that are ordered for each part. And next to the order quantities are the numbers that are received after placing the order. So for part A in scenario 1, I received 990 out of 1,000 that I ordered. I did not receive the full amount. My order for part A is not filled. Here, you can see more statistics for both scenarios. In total, I ordered 10,000 units for both scenarios, but I did not receive the full amount for both scenarios. For scenario 1, 50 units are in short. For scenario 2, 4,000 units are in short. Then we can try to measure the performance of both scenarios using two weights, knife fill rate and order fill rate. Knife fill rate means that for each 100 units that I order, how many units do I actually receive? And based on what we discussed last time, this is the type 2 surface level. This is the percentage fill. And you can see that the knife fill rate for scenario 1 is a lot higher than that of scenario 2 because less units are in short for scenario 1. But for order fill rate, we try to measure the performance by looking at each order. So I either fill the order or I fail to fill the order. For scenario 1, I'm able to receive the full amount that I order for each order. 10 units are being stocked out for each order. So the order fill rate is 0 because none of the order is completely filled. But for scenario 2, although the knife fill rate is a lot lower and more units are stocked out, only one order is not filled. Other 4 orders are completely filled. So the order fill rate is 80%. This means that the same scenario could result in very different interpretations and results based on the tools you use to measure the performance. Sometimes one performance measurement might seem to be good, as you see from scenario 1. A knife fill rate of 99.5% is pretty good, but when you look at the order fill rate, no order is filled, which sounds very bad. After seeing a quite simple surface level measurement, here I will show you a more complicated version of surface level. So the major difference here is that the measurements you see last page consider one order with only one part. So you have 5 parts, A to E, and 5 separate orders. But how about a customer place an order which consists of different parts, like 500 units of A, 200 units of D, and 80 units of E? This is more complicated. So let me give you an example. Unluckily, my car is broken and needs to be repaired. And the technician finds that not only one component is not functioning, but 3 components. All of the 3 components need to be replaced. Without all of them being replaced, my car cannot function well, and the whole job cannot be fixed. That's why in one job, you may ask for multiple part types, and with just a part missing, the whole job is not considered to be completed. So let's go through the symbols on the slides first. Pij means the probability that product J is required by order I. Please be careful that I always mean for the order. J is for the product. P12 means the probability that product 2 is required by order 1. Maybe this P12 equals to 0, which means that product 2 is not needed for order 1. Maybe it equals to 1, which means product 2 is always needed for order 1, or it is just between 0 and 1. The second one, FRI, it means that the fill rate of order I. So FR3 means the fill rate of order 3, and to fill this order, you need all the components being available. And this FRI is going to be dependent on PFRJ, which means the product fill rate. And please be careful, when you are talking about FRI, it is the order fill rate, and PFRJ is the product fill rate. And we can conclude and calculate the order fill rate by using this equation. So finally, this is what I have in mind. My order fill rate of order I equals to the multiplication for order J's, which means all the parts with the expression here. So let's see what is inside the expression. PFRJ is the fill rate of part J. This is the probability that I will not see a stock out for this part J. 1 minus PFRJ would thus means the probability of seeing a stock out for this part J. When I multiply the Pij with 1 minus PFRJ, it means that the probability that part J is being stock out when it is required by order I. And thus, this is the probability that you cannot complete the job. But when I deduct the product of the two terms by 1, this is the probability that part J is available when it is required by order I. It is the probability that you can complete the job regarding this part J. Remember that even if only one part is missing from the order is not completed. So the order is only filled when all parts needed are available. To find out the order fill rate, I have to multiply all the answers from different products in the same order. If I have 5 parts for one order, J would be from 1 to 5. I have to first find out the 5 probabilities that the part is available when it is required by the order, and then multiply these 5 probabilities to find out the fill rate, which is the probability that all of these 5 parts are available when they are required by the order. Here, I will show you a more detailed and realistic example in which we consider one order, which includes 6 products. So I here is 1 and J could be a number from 1 to 6. And you can see all the Pij and PFRJ in the table. If you want to come up with the order fill rate, you have to calculate the fill rate again and again for 6 times for each product, using the equation that we have just talked about. And then multiply these 6 results to get the order fill rate. For example, the fill rate for only product 1 could be calculated as this formula, and it is equal to 0.955. And if we redo it again for other products and multiply all the answers, you can have the order fill rate equal to 0.57, and the average product fill rate will be equal to 0.87. By only judging the product fill rate, you can see that it is quite good because all of the PFRJ is higher than 0.8. And if you add all of the product fill rates and divide it by 6, you can get a high average product fill rate as well. But the real problem is that judging the whole order, the order fill rate is only 0.57, which means that I have only 57% of chance to be able to complete the job. So what can we learn from these calculations? Imagine you are working in IBM. You want to make your customers satisfied, which is to maintain your order fill rate at a high level. You need a very high level of product fill rate for all products, and most likely to be above 95% or even above 99%, or otherwise, after the multiplication of probabilities, the order fill rate is going to be very low. Here, I will try to summarize what we have learned so far. From last lecture, we have learned two types of fill rate. Here, I will try to recapture these fill rates before I move on. Type 1 fill rate is about the probability that all demands are fulfilled within a cycle. So it is like an either-or situation. Either you are able to fill the order demand or you are not able to. In the beginning of this semester, we talk about determining the Z value and using the Z and normal table. We can find this type 1 fill rate. So I would say that type 1 fill rate is easy to determine analytically with the mathematical expression and the normal table. But the drawback is that the amount of unfulfilled demand is not shown. We do not know whether it is missing 1 unit or 100 units. And this does not make a difference here because the calculation does not capture this unfulfilled demand. And that's why we need another fill rate here. We call this type 2 service level. This is the portion of demand fulfilled over the long run. And I have mentioned this already at the start of this lecture. This is the percentage fill and the EN that we compiled last lecture using the table. So this is more difficult to determine analytically, but companies like to use this type 2 fill rate since this is even more intuitive, and this is going to show you exactly the proportion that you are able to satisfy your customers. As this is a more advanced course, we will not stop at these rates, and we will relay them with supply chain management. The graph is plotting the performance of the supply chain, and we are trying to plot the inventory relative to the fill rate. Then you can see an increasing curve, meaning that if I ask for a higher service level, which is a higher fill rate, I should be willing to invest in more and more inventory. For example, if I'm opening more quota of my course, more of you are able to enroll in my course, and I can satisfy more students and thus have a higher fill rate. But if you set a higher reorder point, meaning that you build more inventory, sure, your fill rate will be higher. But as you can see, the relationship is not linear, it is a convex line, meaning that at the start, even a small increase in inventory will give you a huge increase of fill rate. But if you want to increase the fill rate to further right, like from 99% to 100%, you need to have much more inventory, a lot more than before. As an inventory planner, most of the time, you have to compare your competitors' performance with the efficient frontier of your company, which is the best performance curve for your company so far. And if you can also estimate what your fill rate would be for different amount of investment in inventory using the efficient frontier. Some companies might not be able to reach this best performance curve. If the company's performance lies in the green area, it means that the company reserves more inventory, but it cannot achieve the expected fill rate. So we call this an undesirable performance, and this is inferior to the points on the efficient frontier. But there might be some companies that perform even better than your best performance. These companies might invest the same amount of money to inventory as your company could do, but they achieve a higher fill rate. Their performance would be in the brown region, and this is a desirable region. And what supply chain management will do is to adopt best strategies and thus pushing this efficient frontier further to the right. Companies at last increases their fill rate with even a lower inventory level, which is to the desirable region. Here you can see another fill rate, which is fill rates with time windows. This means that there is a time limit for filling the order. For example, a supermarket is looking for instant fill, such that all customers can buy the items without seeing an empty shelf. So the T must be 0. But for companies that order goods from factories, they have to wait for the goods to be produced, and the order could be more flexible. If the order takes quite a long time to finish, the company might want to adjust their order size after having their sales forecast revised. For example, there might be some agreement between two parties that the order has to be filled within 60 days, and the order size is revisable to a certain extent within the first 10 days. So T equals to 60 and tau equals to 10. By that, the customers want some flexibility such that the company can adjust the order amount within a certain time. However, supplier wants more certainty and have a shorter tau, so the supplier and customer might negotiate regarding the contract terms. This is what we are going to observe in reality. This graph is plotting the fill rate with respect to tau, which is the time allowed to adjust the order, and tau could be any number from 0 to T. When tau is 0, it means that the order size is not adjustable. If tau equals to capital T, the customer can adjust the order size at any time within the contract time window. But it is quite unrealistic for tau equals to T, because you can still revise the order even in the last day. No supplier will want to do this kind of an order, so the fill rate will be 0. For customers, they will hope that the supplier will be able to provide a very high service level, and they will expect a higher fill rate when tau is getting smaller. But when tau is getting smaller, the increase in fill rate is getting smaller as well. Judging from the supplier's point of view, of course, the curve will be increasing as well, but not at the same trend as the customer desire. If the customer is asking for a very high service level, suppliers will be more careful to their inventory level, because to provide a very high fill rate, they have to reserve a lot of inventory. But if suppliers reserve a lot of inventory and customers cut half of their order, suppliers may suffer from high holding costs. So if tau is large, the supplier will not promise a large fill rate. They will try to play safe, so the curve is increasing slowly at a larger tau and increasing faster at a smaller tau. The difference in desire level between supplier and customer is fostering a negotiation, and eventually they would reach an agreement with a curve between the area of the two curves. So fill rate themselves do not just reflect the performance of supply chain, but they are also vehicles for communication and negotiation between two companies in a supply chain.